Okay, guys, so in this video, I'm going to talk to you about transformations. And the way I'm going to do that is I'm going to go through some questions, these questions right here. I will start in this video just going through this first batch of questions here, and I'll just do the even ones. So that is to say I will do questions 8, 10, 12, 14, 16, and 18. All right, so what are transformations? Well, I'll give you the rules, which are right here. So transformations are how we move a graph around, how we move a function that we have graphed around. So I'm going to use the Desmos graphing calculator right here to give you an idea of how we do that. So these are the actual rules right here. If we're given a function, y is equal to f of x, and we want to shift that function up or down vertically, then we will add a value plus k or minus k. So let me just give you an example. If I have a function, the simplest function I think of, y is equal to x squared, and if I want to move that function up or down, then by a certain amount, let's say I want to move this function here up by 2 units, then I simply say I take plus 2, and that will shift my function up 2 units. If I wanted to shift my function down 2 units, here's my original function again, y is equal to x squared. If I wanted to shift it down 2 units, I would simply take my original function, y is equal to x squared, and subtract 2. So that there is now, this is f of x minus 2. My original function, f of x, is x squared. This is x squared minus 2 right here. So by adding or subtracting a value k is assumed to be greater than 0, so it's a positive number, that raises or lowers my graph of f by k units. If I want to shift my graph left or right, so these are what we call horizontal shifts, so moving the graph left or right, then what I will do, just go back to my original function, is I will replace my function, or replace the x value of my function by x plus h if I want to shift the graph to the left, and x minus h if I want to shift my graph to the right. So again, here's my original function. If I want to shift this graph to the right, this direction, say 4 units, so I want to take this graph and just shift it over to here, then I need to replace my x by x minus 4. So if I want to shift it to the right 4 units, then I replace it by x minus 4. So let me just put it down here. If my function is y is equal to x squared, and I want to replace x with x minus 4, then that is the function x minus 4 parentheses squared. And so this is my function now shifted over 4 units to the right. It moves to the right when I have a minus sign here. Okay, what if I want to get rid of that? If I want to move my function to the left, well, if I want to shift it to the left, it says here h units, well then I add x plus h. I replace my x in my original function with x plus h. So here's my original function, y is equal to x squared. If I want to move it to the left, say again, let's say 4 units, so that is to say I want to go from here to here, then I'm going to replace x in my original function with x plus 4. Let me do that. That will give me x plus 4 squared. And now my function has moved to the left 4 units by replacing my x in my original function with x plus 4. That is the effect of replacing x with x plus 4. It shifts my function to the left 4 units. Okay, so I'm going to just leave that there. I'm actually going to get into the questions. There's a few other things, but I think the easiest way to go about explaining it is to just actually do some problems. All right, so like I said, I'm going to go through these even number problems. So starting with number 8. It says in problems 7 through 18, match each graph to one of the following functions without using a graphing utility. So we're actually given here, the original function we're given is y is equal to x squared. So it's the function we just had. So I will actually just take this y is equal to, I will put in here, again, x squared. All right, so that's the original function that we're actually given in these problems. So what has happened is that the function y is equal to x squared has been moved around. And what we're asked to do is we're asked to work out how has it been moved around. So here in question number 8, I have the function y is equal to x squared that has been moved to the right 2 places. It has been moved to the right 2 places. Well, if I was to go back, how do I move this function to the right 2 places? I replace x here with x minus 2. So that would be my function, put it here, would be x minus 2 squared. I can confirm that that is what would happen. If I replace x with x minus 2, then that shifts it to the right 2 places. And that's what we have here. And so do we see that up here anywhere? We do. That's answer number E. Y is equal to x minus 2 squared. So for question number 8, this graph here, question number 8 goes with E. Y is equal to x minus 2 squared, as you can see right there. Okay, so that's number 8. Number 10. All right, so I have to talk to you just about this graph real quick. All right, what graph have we got here? So I will show you the graph of the absolute value of x. So the absolute value of x is that graph right there. And so this is the graph of the absolute value of x. You can see that the graph kind of makes sense. If I have an x value of 4, say, then the absolute value of 4 is 4. So I have that point there. If I have an x value of negative 4, well, the absolute value of negative 4 is also 4. And so the domain of this function, the absolute value of x, is negative infinity to infinity. You can put in any values of x you choose. But the range is from 0 to infinity. So the range does not include negative numbers. Right? So the range, which is measured on this axis, the y-axis, goes from 0 to infinity. So there are no negative values in this function. So this is the original function. And what we're asked to do is, well, what has happened to that original function in order for it to look like this here in number 10? All right, well, 2 things have happened. It has been flipped upside down. It has been inverted. I'm going to talk to you about that in just a second. And it has also been moved upward. Right? So it has been inverted and it has been moved upward. Okay, so how do we invert? So it has been flipped across the x-axis. That's really what has happened. It's been flipped across the x-axis. In order to flip across the x-axis, I'm going to go back to my original rules. Here we have reflection about the x-axis. If you take y is equal to minus f of x, reflects across the x-axis. So all you're doing is you're multiplying your original function by minus 1. So if I go here to Desmos, here's my function y, the y is equal to the absolute value of x. That's my original function. If I simply put a minus sign in front of this, it flips it across, so you can see a little better. It flips it across the x-axis. That is the effect of that minus sign. It reflects it across the x-axis. So this is, given the original function f of x, this is minus f of x. Minus f of x, taking the negative of the function, will always flip it across the x-axis. What else has happened? It has been then shifted up 2 units. Shifted up 2 units. How do I shift a graph up 2 units? I add 2. I say plus 2. That shifts it up 2 units. And so this here, minus the absolute value of x plus 2, minus the absolute value of x plus 2, this is what will lead to this function right here. Do I have that here anywhere? Hopefully I do. Yes, I do. It's D. y is equal to minus the absolute value of x plus 2. That is D there, which is what we have here. So that is what has happened. And so that's number 10 done. Number 12. Okay, for number 12, I have the parabola again, and it looks like I have the function y is equal to x squared that has been shifted. How has it been shifted? It has been shifted up 2 units. Okay, so let me go back here. I have the function x squared. We know what that looks like. Seen that many times now. And it has been shifted up 2 units. How do I shift up 2 units? Raise the graph up of f by k units. You simply add that number. In this case, that's 2. So that's plus 2. And that raises my function up by 2 units. And so that is what has happened. I have my function y is equal to x squared has been raised up 2 units. That gives me the function y is equal to x squared plus 2, which is this one right here. So no, for number 12, the answer is A. This is y is equal to x squared plus 2. Okay, number 14, I'm back to this graph, which is the graph of the absolute value of x, and that has been shifted around in some way. How has it been shifted around? Again, it looks like it has been simply moved up 2 units. 1, 2 units right there. So again, just put that here so we can see it. That's the absolute value of x. That's what that looks like, but it has been moved up 2 units. How do I move a function, any function up 2 units? I simply add 2. Plus 2 brings it up 2 units right there. So I'm looking for the absolute value of x plus 2. Is that here? Yes, it is. It's C. Y is equal to the absolute value of x plus 2 is the answer to number 14. So 14 goes with C. 16. Okay, in 16, 2 things have happened. Okay. One has been flipped over. And the other thing that has happened is that it has been stretched stretched vertically. It's been stretched vertically. So let me just, this is our function, our original function is y is equal to x squared. That's my original function. If I want to stretch this function vertically, make it, as it were, narrower, make the space from the distance from here to here smaller, make it narrower, I will multiply my function by a constant greater than 1. So in this case, given the options that are here, it looks like the number they're using is 2. And so I would have, if I take 2x squared here, now my function has been stretched vertically. The distance has gotten smaller. If I had multiplied my function by a constant that is between 0 and 1, so let's say 0.5. So if I have 0.5x squared, you can see that it is compressed vertically. It gets wider. So it gets wider right here. My green is my original function. This purple function here is 2x squared, and 0.5x squared is this one here. So it compresses vertically if the constant that you're multiplying your function by is between 0 and 1. If it is 1 or greater than 1, then it is stretched vertically, as you have right here. Okay, so to go back to our problem, 2 things have happened. It has been stretched vertically. That is to say that this space here is narrowed. You can see, compare it to number 15, right? It is narrower. And so it has been multiplied by a constant greater than 1. And it has also been flipped over. And so to flip it over, just get rid of this, don't need that. Flip it over, I have to multiply the function by -1. That is flipping it across the x-axis by minus. That flips it across the x-axis. Again, if I go to my rules, reflection across the x-axis, I multiply my function by -1. So that flips it across the x-axis. And then to compressing and stretching is right here. I've multiplied my function by a constant a, where a is greater than 0, and then they give the rules right here. You stretch the graph of f vertically if a is greater than 1, and you compress the graph of f vertically if a is between 0 and 1. So 0 0.5, 0 0.25, etc., etc. And so that is what we have here. What we have here is this graph right here, minus 2x squared. Minus 2x squared is j. Y is equal to minus 2x squared is j. That's that one right there. All right, and then finally number 18, similar. We can see that what we have is that our function, the absolute value of x, has been stretched vertically again. Right? It is the distance between here and here is narrowed. So to go back to my function, the absolute value of x, there's the absolute value of x. If I want to stretch this vertically, then I need to multiply it by some constant greater than 1. So let's take 2. So 2 times the absolute value of x is that one right there. So it's this blue. So you can see the difference is that, like I say, it has been stretched vertically. The distance here between any 2 points right here has gotten smaller. And that is it. It hasn't been moved vertically or horizontally. The vertex here is still on the origin, and so that's the only thing that has happened to it. And so we're looking for 2 times the absolute value of x, which is k right here. Y is equal to 2 times the absolute value of x. And that is what has happened to this function right here. Okay, so that is the even number problems completed. And that is a first look at how we go about transforming a function in this way.